So charting on chapter A, we're going to deal with systems of equations. So we're going to just solve linear equations, and we're going to solve two variable systems. So all the equations in the form ax plus by equals c are straight lines, because this is the standard form of a linear equation. So these are all going to make straight lines when graphed. Two such equations are called a systems of equations or a linear system. So if I have two equations, like this, what we have here is considered a system of equations. And usually we put a little set like that to say they go together. So it's saying that there's a set of two sets of equations. A solution to a system of equations in two variables is an ordered pair that satisfies both equations in the system. So usually what we're looking at is we have two lines, and at some point those two lines are going to cross. And the solution that we're going to have at this intersection is a solution to both lines. So that's usually what we're looking for. So a linear system that has at least one solution is going to be called consistent. So at least one solution. So sometimes you can have multiple solutions. A system with no solution is called inconsistent. So this would be the one where you'd have no solution. Oh, it says right there, no solutions. Sorry. So this one is either going to be one solution or maybe infinite solutions. So we're going to consider the system 2x minus 3y equals -4, and then 2x plus y equals 4. We're going to determine if the ordered pair is a solution to the system. So we have an ordered pair, so we have an xy pair. So we want to see if it is a solution to the system, it's a solution to both equations. So we're going to have 2x minus 3y equals -4. And we know our x is 1 and our y is 2. And then we also have 2x plus y equals 4. And we know that it's 4. And we know that x is 1 and y is 2. So we see here we get a 2 minus 6 equals -4. 2 minus 6 is -4. So we get -4 equals -4. So we get 1, 2 is a solution to 2x minus 2x minus 3y equals -4. Here we're going to have a 2 plus 2 equals 4. So we get 4 plus 4. So we see that 1, 2 is a solution to the equation 2x plus y equals 4. So we get, wrote it backwards, that 1, 2 is a solution to the system. So as long as it's a solution to all my equations in my system, it's a solution to my system of equations. So just to show you graphically, this is our line of 2x minus 3y equals -4. And this is our line for 2x plus y equals 4. And what we see is they both intersect right there, right in this spot. So if I touch that point, we see that we get a solution that is 1, 2. So once again, this is just showing us that that is the solution to our system of equations. So the intersection, this is a point that is a solution to this line and to this line, therefore it's a solution to the system. To take a moment with this system of 2x minus 3y equals -4 and 2x plus y equals 4, so the same system, we want to determine if the ordered pair x6 is a solution to the system. So take a moment and see if that is actually a solution as well. So once again, This is my x, this is my y, so I have 2 times 7 minus 3 times 6. Does that equal negative 4? Well, we get a 14 minus 18. So we get minus 4 equals minus 4. So 7, 6 is a solution to 2x minus 3y equals minus 4. Now is a solution to 2x plus y. So we got 2x, so 2 times 7 plus y, which is my 6, equals 4. So I think pretty easily we can see this is going to be a problem because we're going to get 14 plus 6 is supposed to equal 4, and we get 20 equals 4. So what we have here is that 7, 6 is not a solution to 2x plus y equals 4. Since this is not a solution to one of my equations, what we have is that 7, 6 is not a solution to the system of equations. And if you remember when we went back, we did graph these two intersected at 1, 2. That is the only solution that we have there. So you can find other points that may be a solution to one line or to the other line, but if they're not a solution to both lines, then it is not a solution. So a point has to be a solution to both lines. Or in the case of 3 lines or 4 lines, it has to be a solution to all of our lines in the system of equations. So we're going to solve a system of linear equations using substitution method first. So to solve either the equations for one variable in terms of the other, so we take one equation and solve for x or solve for y. And then we are going to substitute the expression found in our first step into the other equation. So never substitute into the same equation. Always has to be the other one. We're going to solve the system containing one variable, and we're going to solve for that one variable. After we get it, we are going to take what we solved for the one variable, and we're going to put it back. Put it back into one of the original equations and solve for our remaining variable. And then after that point, we should check to make sure that our solution, or x and y, is a solution to both lines. We'll do that the first time, but we won't keep doing that last step of checking. Like I said, just to save us a little bit of time. So what we mean here is I got 3x plus 2y equals 4 and 2x plus y equals 1. So we already used this system already. We know what the solution is, but we're going to see how we get it. So a lot of times we just label these lines. So this is going to be equation 1 and equation 2. So I'm going to take equation 2 and I'm going to solve equation 2 for y because that will be easy. So 2x plus y equals 1, which means that if I want y by itself, y is just 1 minus 2x. So we're going to substitute. We're going to call this a new line. We're going to call it y prime since it's still, or not y prime, 2 prime, since it's still 2, it's just rewritten. But we're going to substitute my 2 prime into line 1 now. So like I said, you're always going to put it into the other equation. So what we're going to have is 3x plus 2, and my whole y here is now going to be replaced with 1 minus 2x. Supposed to change color, and that did not happen. So we're just taking that and we're just putting it in here. And then we said that this should equal, because this is line 2, equal 4. So now we're just going to solve for x. So we have 3x minus 2 times 1 minus 2x equals 4. So that is going to be 3x plus 2 minus 4x equals 4. If we simplify this, is going to be 2 minus x equals 4. If we subtract 2 from both sides, we get negative x is equal to 2. And if we divide both sides by negative, x is equal to -2. There's a mistake. Just a minute here. No, there's not a mistake. This just looks similar to the lines that we had last time. It's not exactly the same. So no, it is x is equal to -2. Now we're going to solve for y. And what we could do is usually we just use this line here. So we just use that y prime that we had and see if, because we already set it up for y. So we got y is equal to 1 minus 2. And we just said that x is -2. So we're going to put -2 right here. So we're just substituting back in one more time. And we get is y is equal to 1 plus 4. So y is equal to 5. So I'm saying that my solution to the system of equations is going to be -2, 5. All right. So like I said, once we find an answer, we should check it. And I'm not going to check all of these. I'm just going to check this first one. So if we check, we're saying that the solution is going to be -2, -5. Or sorry, -2, +5. So if we go into equation 1, that means that is 3 times -2 plus 2 times 5 equals 4. We get -6 plus 10 supposed to equal 4. 4 equals 4. We have the solution. It works out. If we use equation 2, we get 2. X is going to be -2 plus y, which is 5, equals 1. So we get -4 plus 5 equals, let's look at the wrong thing, 1. -4 plus 5, we want to see if that's going to equal 1. So we get 1 equals 1. That checks out. So this is the solution to my system, right here, solution to the system of equations. So take a moment here and try to solve the substitution method. So you have x minus 3y equals -9 and 2x plus 7y equals 8. We want to find a solution to this system. And then we want to find a solution to this system, 11x plus 2y equals 14 and y equals -4x plus 1. Okay, so hopefully you had a chance to work on this. Sorry, so not let me change my color here. So we're going to have line 1 and line 2. So 1 looks like it'd be easiest to solve for x. Because if we have x minus 3y equals -9, well then x is just 3y minus 9. Oh, excuse me here for a second. So now we're going to substitute. And like I said, I'm going to call this 1 prime because it's still the same equation. It's just rewritten. So we're going to substitute 1 prime into the other equation, so our 2. So we got 1 and we're going to substitute 1 into 2. So 2 is going to be 2. Then we have our x. And we said x is going to be 3y minus 9. Okay. So lost my line there for a second. So now we have this line here. We have in equation 1 variable y. So we're going to solve for y. So we're going to have 3x minus 9 plus 7y equals 8. So we're going to have 6y minus 18 plus 7y equals 18, or sorry, 8. Too many 8s and 18s. If we combine this, this is going to be 13y minus 18 equals 8. If I add 18 to both sides, I get 13y equals 26. And we get that y is equal to 2. So now what we're going to do is we're going to use our y prime again, or 1 prime, to find, I keep calling it y because I'm using calculus terminology here. We want to use 1 prime to find our x now. So we said that x is just a 3y minus 9. Well, we just said that y is going to be 2. So x is going to be 6 minus 9, or x is just going to be negative 3. So I'll put it up here, but our solution is the ordered pair. X is negative 3, y is 2. And we're not going to double check this one. I had already checked it ahead of time, so that is the solution. All right, so for this one, we actually already had one of our lines was in the form of y equals negative 4x plus 1. So we do not have to solve one of our equations for x or y. So sometimes we have situations like this. So all we're going to do is we're going to substitute 2 into 1. So we see that we're going to have 11x plus 2. And what we said y is here is negative 4x plus 1. And all that should equal 14. And then we're just going to solve for x. So we get 11x minus 8x plus 2 equals 14. So we are going to have 3x plus 2 equals 14, which means we're going to have 3x equals 12 when we subtract the 2. And so we end up with that x is going to be 4. All right. So at that point, we are going to use line 2 to solve for our y now. So y is going to be negative 4x plus 1, or y is going to be negative 4 times 4 plus 1. So negative 16 plus 1 equals negative 15. So my solution to the system is going to be x is 4 and y is negative 15. So substitution method is a very nice method. However, we're trying to build into matrices eventually. So what we're going to do when we get into matrices, and also this will help us with more larger systems of equations, is that we use what we call addition method, or you may have heard this being called elimination method. So I like the term elimination method because the idea here is that we're actually trying to eliminate one of our variables. So if necessary, we want to rewrite both equations in the form of ax plus by equals c. So we want to make sure they look like this. So we get our x term first, our y term, and then our constant on the other side. So if necessary, we're going to multiply either equation or both equations by an appropriate non-zero number, so the sum of the x coefficients or the sum of the y coefficients is 0. So what we're trying to do, if I have an ax plus by equals c, and let's say we have a dx plus ey equals f, we're trying to add this up in a way that either the a and the d are just going to disappear and we'll get a 0, or the b and the e will add up and give us a 0. That's what we're trying to aim for. Is we're trying to make either x's disappear or y's disappear. Then we're going to add the equations in step 2. The sum is the equation in one variable, because if we eliminate our x's or our y's, we're just left with the other variable. And then we're going to solve the equation in one variable. After which, once we have an equation in one variable, we're going to back substitute the variable obtained in step 4. So the one variable equation here. So once we get that, we're going to substitute into using that as one of the variables in one of the other equations, and then trying to figure out what the other variable is. And once again, we should be checking our solutions. But like I said, I already checked all these solutions for us, so I'm going to save us the time of the checking. So when we say elimination method, we have 4x plus 5y. I'm actually going to give myself a little bit more space here. So this method may seem like a lot of extra work, but once you get into more involved systems of equations, it may be an easier method to use. There we go. So we're going to have this 4x plus 5y equals 3, and we have 2x minus 3y equals 7. So what we're going to do is we're going to multiply either one or both of these equations by something so that these coefficients out front will eliminate. So either we can try to eliminate from x or we can try to eliminate y. So if you notice here, I got a 4x and a 2x. So if I take the bottom equation and we just multiply the whole thing by -2, it's going to be the same equation because both sides are going to get multiplied by that -2. What we're going to get is a system where we have 4x plus 5y equals 3. But now that everything on the bottom, this second equation has been multiplied by -2. -2 times 2x is -4x. -2 times -3y is going to be 6y. And -2 times 7 is going to be -14. Okay. Once we get to this point, we got these two equations. We're going to add them to each other. And what we find is that this -4 and this +4 and this -4 cancel, and I'm left with 0 x's, 11 y's, and -11 over here. So 3 minus -14. So that is just 11y equals -1. So if I solve for y, we get y is just -1. And that is what addition method is. So like I said, we're just multiplying one of our equations by a constant so that when I add my two equations together, a variable disappears. So once I get that, just go back and pick one of your equations. So why not this one? We have y, now we're just going to solve for x. So 2x minus 3, we said y is -1 equals 7. So we got 2x plus 4 equals 7. It's going to go, and I did something really silly there. -3, -1, plus 3 equals 7. There, that's going to make more sense. Subtract the 3. We get 2x is equal to 4. So x is equal to 2. So like I said, you can check this. So x is going to be 2. So 4 times 2 plus 5 times y, which is -1, equals 3. So we get 8 minus 5 equals 3. 3 equals 3. So it was a solution to this equation. That was if we found a solution. So we got 2 times 2 minus 3 times -1 equals 7. So we get 4 plus 3 equals 7. 7 equals 7. So what we have here is that 2 and -1 are solution to this one as well. So the solution to the system of equations is x is 2, y is -1. So they're xy pairs. All right, so give you a couple of varieties of these to try. So try addition method. So this one's very similar to our first one. Here, you're going to actually have to multiply both equations by a constant so that you can make a variable eliminate. So this one you only have to multiply one by a variable, but for this one you have to multiply two, not variable, I'm sorry, multiply only one equation by a constant, and then this one both equations by a constant. So I'll give you a chance to work those out. And it doesn't matter if you try to eliminate x first or y first, just pick one to eliminate first. Okay, so we may not have all done this the same, so I'm just picking one method here. So first thing we want to do is we want to write everything in terms of ax plus b, or sorry, ax plus by equals c. So we see that here, ax by equals c. I'm making myself that extra space again. I grabbed the wrong thing there. There you go. So we're starting out with 6x minus 8y equals 5. Then if I rewrite this equation, so I have 12x, so my x's are on top of each other. If I add 10y over here, then this equation can be rewritten as 12x plus 10y equals 23. And now I have my ax plus by equals c. Okay. So once again, it looks like x would be the easiest to get rid of because this is 12x and 6x. So all I have to do is multiply this by -2. So what we'll have is -2 times 6x is going to be -12x. -2 times -8 is going to be plus 16y. -2 times +5 is going to be -10. And then the bottom one stayed the same. So we have 12x plus 10y equals 23. So we're going to add our equations together. So minus 12x plus 12x is going to leave me with 0x. 16y plus 10y is going to leave me with 26y. And -10 plus 23 is going to leave me with 13. So I have 26y equals 13. If I divide both sides by 26, y is equal to 1/2. Okay. So like I said before, just pick one of your equations. I'll just pick this one. And now we're going to solve for x. So we have 6x minus 8, and we said y is 1/2, and that's going to equal 5. So we have 6x minus 4 equals 5. If I add 4 to both sides, I'm going to have 6x is equal to 9. Divide both sides by 6, x is going to be 9 over 6. And if I reduce that, x is just going to be 3/2. And this is one, like I said, I had already checked this one. So my solution to the system equations is going to be x first, which is 3/2, and y is 1/2. So we said this one was going to require us to multiply both equations by some sort of constant. So we have minus 5x plus 2y equals 9. And we have 2x minus 3y equals -19. Now, I can't, in the other case, like I could double one side and I'd have something that was the same number, just a different sign, right? So I have a -5x and a +2y. Just going back to see what I did. Okay. So what I can do is I can multiply this by 2. And I can multiply this one down here by 5. Because if I do that, this is going to be a negative 10x, and this is going to be a positive 10x. So like I said, it doesn't always have to be x. It's just the one we're tackling right now. So if I go back and I get my new equations, so 2 times negative 5x is negative 10x, 2 times 2y is 4y, and 2 times 9 is 18. Then here, 5 times 2x is positive 10x, so my x's are going to cancel. 5 times negative 3y is negative 15y. And 5 times negative 19 is going to be negative 95. Now if I add those, I lose the x's again, and then I have 4y minus 15y, so that is going to be minus 11y. And then 18 minus 95 is going to be negative 77. So I'm going to end up with negative 11y equals negative 77. Y is just going to be 7. So as I said before, just pick one of the equations. Well, let's pick the bottom one. We picked the top one last time. So we already solved for y, so we're going to solve for x. So we got 2x minus 3, and y is 7, equals 19. So I have 2x minus 21 equals negative 19. If I add 21 to both sides, I get 2x equals there we go. Okay, I have to make sure I was in the right place. I thought something wasn't lining up here. So 2x is going to equal 2. So then we're going to get x is just going to equal 1. So my solution is 1, 7. So alternatively, instead of trying to eliminate x first, you could try to eliminate y first. So in that case, you see we have a 2y and a negative 3y. So if I multiply this by 3 and the bottom by 2, we'd see that we would end up with a 3 times 2, so that's going to be a positive 6y, and a 2 times negative 3y. So we'd have a 6y minus a 3y. So when those add together, y would disappear. So if I continued that, that'd be negative 15x plus 6y equals, 27. And then we're going to have on the bottom, 4x minus 6y is going to equal, second, I gotta double check that I did that one right in my head. 18 times 2. Yeah, negative 38. So once we do that, we're going to get a minus 11x plus 0y is going to be equal to negative 11. So we're going to get negative 10x is equal to negative 11, which means x is equal to 1, which is what we had last time. So just pick one of your equations. We have x, now we're just going to solve for y. So we have negative 5 times 1 plus 2y equals 9, which is going to be minus 5 plus 2y equals 9, which is 2y equals 4 plus 14, and y will be equal to 7. So once again, got the same solution, it's just I eliminated y first. Now, as we mentioned before, the cases we had one solution. So as we've shown, that's when you have two lines intersect. You get a solution. So other things can happen, which is you have two parallel lines like you have right here. If you have two parallel lines, they're never going to intersect. And in that case, you're going to have no solution. There's also the case that we've seen this before when we were talking about solving equations, that you could have two lines that look like they're different lines. The equations might look different, but the line itself will be identical, which is what we have there. In that case, we have infinite many solutions, and the solutions are all the points along the line. So we are going to look at the system with no solutions and see what happens. So we have 5x minus 2y equals 4, negative 10x plus 4y equals 7. So if we try to eliminate, let's say we want to eliminate y. All I have to do is just double all my numbers here. So just multiply this by 2, and I'd have a negative 4y plus a 4y. So if I multiply everything by 2, I'm going to get 10x minus 4y equals 8. And then the one on the bottom, we didn't change that, so that stays negative 10x plus 4y equals 7. So what we're going to see here is, well, this is not what we intended. We intended to make the y's disappear, but we see that the x's disappear and the y's disappear. So we will have 0x, 0y will equal 15, which means 0 equals 15, which we know cannot happen. So we get an inconsistent system. And we have no solutions. So let me graph this one here in a second. So if you see, if I graph the lines, they are parallel lines. So we would not have a solution. Now here, we're going to have a system with infinite many solutions. So we have x equals 4y minus 8. So if we rewrite it, remember, as 8x plus by equals c, that is going to be x minus 4y equals negative 8. The other we can keep the same, so that is 5x minus 20y equals minus 4. So if we want to eliminate the x's, all I'd have to do is just multiply everything on the top by minus 5. And we would have minus 5x plus 20y equals 40. And on the bottom, we didn't change anything, so that stays 5x minus 20y equals negative 40. If we add that together, we have 0 x's, 0 y's, and 40 minus 40 is 0. So we get 0 equals 0, which means that's true for all solutions of the line x equals 4y minus 8, which is actually the same as that line. So the lines are the same. So we would say we have infinite solutions. All our solutions are just going to fall along the line because they're going to be the same line. So here, this is x equals 4y minus 8. So before we rewrote the line, and if I turn on 5x minus 20 equals negative 40, we see that they sit on the same spot. So all solutions to the line are solutions to the system. Basically, our system of equations is really just a line. So from number 6 here, you have two sets, and you're just trying to determine if there is no solution, infinite solutions, or only one solution. Okay, so if you try this, but starting with A, if I rewrite this so that's 8x plus by equals c, so my x's first, then my y's, it's negative 3x plus y equals 2. And then 6x minus 2y equals -4. That does not have to change. Now, if we wanted to try to eliminate x, we just have to multiply the top by 2. So if we do that, we have -6x plus 2y equals 4. And the bottom didn't change, so we keep 6x minus 2y equals -4. So we see 0x, 0y is going to equal 0, or 0 equals 0. So we have infinite solutions. So here, we don't have to change the order of anything. So we just have 3x plus 2y equals 3, and then we have 6x plus 4y equals -8. So if I want to get rid of, say, my x's, this is already 3x, 6x. So if I multiply by -2, I'll get a -6x. So we're going to get -6x minus 4y equals -6. And then we still keep the 6x plus 4y equals -8. I forgot to put my addition over here. So if we add that, we get 0 x's, we get 0 y's. But here, we don't get 0, we get -14. So 0 equals -14, which can't happen, so we have no solutions.